Once you look it up on your phone, why don't you write down the list of questions and then you won't have to keep looking.
Yeah.
In
All right.
fact,
So it's
give it to me
it's
so I can write it down. What?
okay. So it's 12 through 26 even.
12 through 26 evens on this
Yeah.
page.
And then 29 through 31.
Okay. I must
Then 30.
this must not be the first page. I must have an earlier page, huh?
Yeah, yeah. They're probably kind of scrambled.
Okay, here, let me try to find that earlier page. You happen to know, let's see, it's got a 12 on it. This must be it. Okay, let me download this one and bring it up.
Yeah, that's the first page.
Yeah. So 12 through 26 evens. Let me go ahead and take a snapshot of this. It's the derivative of 12.
Mm-hmm.
What's the derivative for number 12?
It would be 100 v to the 99th power.
Okay, how about 14?
Here, give me a moment. 14. That would be.
Yeah, actually, you want to be able to do these without your book. If
What?
Well, I hear pages turning. I don't know. Are you turning to this page or are you turning to the formula for the power rule?
I was just turning on my like notebook so I could like write these down as we go.
Okay.
Yeah.
So 14 is going to be what? This one here.
14. That would be. It would be. Here, let me do the math in my head. 55 sixths.
Here, let me give you an easier way to do that, Jake.
Oh wait, no.
12
60.
times 5/6, right?
Mm-hmm.
And we know it's W to the 11th. When you're doing 12 times 5/6, don't do 12 times 5 and divide by 6. Do it this way.
Okay.
That's 10W to the 11th. In other words, work with as small a numbers as you can always work with. I don't want to multiply 12 times 5 and get 60 and then divide 60 by 6. I'd rather simplify it first by dividing top and bottom by 6 so that I end up with 2 times 5 is the answer.
Okay.
Okay, how about 16?
16. Would it just be?
Let's rewrite 16 first of all. Tell me how I can rewrite 16. Remember, radical signs don't work.
6t to the 1/2.
Okay, now apply the power rule.
It would be 3t negative 1/2.
Now, if she said put that back in radical, what would it be?
In radical form, it would be. Would it be root negative square root of 3t?
No. First of all, the negative exponent does not have anything to do with negative. Merely means it's on the other side of the fraction bar.
Oh, yeah, yeah.
So it's 3 over t to the plus 1/2, which is the same as 3 over the square root of t. So there's your answer. But I wanted to make sure you knew that how to get from one of those to the other, because you got to be able to go back and forth all the time between these.
Okay.
Okay?
And then 18.
Yeah, so rewrite 18. So f of s is what?
1/2 s to the 1/2 plus 4 to the -1.
No, we can treat that 4 as the fraction 1/4.
Okay, so
Notice,
times.
let's just talk about that for a second, because you got to be totally cleared up on these. If I were to write something like this, that's the same thing as this problem. Dividing by 4, I can remove that 4 as a fraction, 1/4. And once you make it 1/4, now you can apply the power rule. And as long as it's divided by 4, it's harder. In other words, you gotta, to apply the power rule, you pretty much have to make everything, you don't want to be dividing by anything. You don't want to be dividing by variables. You don't want to be dividing by numbers. Anytime you see something being divided, pull it out as a fraction. Now, what's the derivative of that?
Okay, so it would be so I am thinking it would just be 1/8.
There you go. Always, when you're doing the power rule, start there. Always. That's just an automatic starting spot. 1/2 times 1/4 s, and then subtract 1 to the -1/2. So now put that back in radical form.
So it would be s to the -1/2. Oh wait, no, you could put that down. So it'd be 1/8s to the 1/2.
Or if we want to put it in radical, it's like that.
Okay.
Exactly. Exactly. In other words, that 1/8 now goes back as a division by 8. If I want to put it into the similar format as they gave it to us. Not that you necessarily need to know how to do that. They may never ask you to put it back in radical format. You kind of want, you learn pretty quickly in calculus that radicals don't work well. So you won't be dealing with radicals for very long, I don't think.
Mm-hmm.
Just because, you might, but they all need to be converted to a fractional exponent, always.
Okay.
It doesn't matter whether you're using the power rule, the product rule, or any of them. Okay, so let's see, 12 to 26 evens. Next one is 20. What's the derivative of 20?
Okay, so that would be 30x to the 4th -1.
Perfect. 22.
22.
Now, first of all, let's rewrite it here. What you're seeing here is, it is true that the derivative of the sum or difference of a bunch of things is the derivative of each one individual. Not true about products, just so you know. That's why there's a product rule. In other words, if I'm multiplying two variables together, say I have x times sine x, like that, and that's my function, I don't have a product rule. I don't have a power rule for that. I know what the derivative of sine is, but you need more than that. Now you got to use a power rule, what's called a power rule. And if we have time, I'll go over that with you. It doesn't look like we're probably going to have time, but not if we want to cover all these. The product rule is not hard. It won't be hard for you to learn either. Okay, so we got 6t to the 1/2 minus 4t cubed. Is that plus 9?
No.
Is there something after the 9 that I can't see on this page?
No, it's oh yeah, sorry. Yeah.
It is just plus 9?
Yeah.
Okay. So what's the derivative?
3t to the negative 1/2 minus 12t squared.
And that's the answer you want to go with. I wouldn't bother unless the teacher specifically says she wants it back in radical format. In other words, some of them might tell you that if they give it to you in radical format, give the answer back to them in radical format.
Okay.
Okay. So rewrite 24.
24. Okay, so that would be 4 t to the 1/2 minus 1/4 t cubed.
Now, first of all, we're just writing the original function without radicals. That's all we're doing. What's that last term?
I have no idea.
That will assume it's plus. I can't tell.
I can't tell either. It just got cut off.
We'll just call it plus t. Even though I can see there's something after that.
Oh no, there's a plus t, but I know there's something after that.
Oh, okay. There's something after that, I'll bet, is a number. We'll make up any number.
Okay.
Okay? Because it won't matter what the number is, it's going to go away, right?
Yeah.
Okay, now what's the derivative?
So it would be 2t to the negative 1/2 minus t cubed plus 1, and that's it.
Now, answer me one question. Why the heck do they start you out teaching that limit quotient definition as opposed to this?
Oh, my teacher had an explanation.
Oh, good. I'm dying to hear it.
He was like, he just wanted us to understand like why it was that way, like and like the patterns of it before we actually did like the shortcut, I guess.
Okay. Okay. Seems to me that that's similar to if I was trying to teach you how to ski, I'd drop you on the steep slope and say, get down however way you can. And then when I really wanted to teach you how to ski, I would start you on the beginner slope. When you mastered it, I'd take you to the medium slope. When you mastered it, I'd take you to the hard slope. That's the way I think anything should be taught, from easy to hard. And yet math, and it's not just calculus, this actually applies to algebra, geometry, trig, everything. They always start you out with some of the toughest material in the entire class. And they start you out at the beginning. And to me, that just seems like it's demoralizing. It makes me think the material is so much harder. I mean, I could see people trying to get through that limit quotient definition and giving up, saying, I can't do that. I'm going to drop calculus and take statistics or something. But so I don't get that as to why they make it so hard. Ooh, this 26.
Is that part of the questions?
Well, you said 12 through 26 evens.
Oh, yeah, okay.
Okay. So, there's two ways to do it. I can multiply it out, so I have one big polynomial, and then I'll just be doing it like we've done all the others. Or I could use the product rule. Now, you don't have the product rule yet, and that's why the instructions say expand it first. So, expand it. Let's see what we're looking at here. What is G of R? I'll write it up here. Going systematic. The key to expanding these is follow a system and always follow that same system. Don't jump around. Don't multiply that times that, and then multiply that times that, and then go back and multiply that times that. You know what I'm saying?
Yeah.
Follow a pattern and stick to it.
All right.
And the pattern I do is left to right. In other words, I do this term, I multiply it by both of those, and then I do the middle term, multiply it by both of those, and I do the third term and multiply it by both of those. Always that pattern. Because it's real easy. Like if you have a triplet times a triplet, it's easy to miss one of them if you don't use a pattern.
Mm-hmm.
So what's the first term? That times that.
Would it be 5r to the 5th power?
Yeah. Next.
Wait, I'm just gonna do it. Yeah, so then it'd be 15r cubed.
You need a sign in front of that.
Plus 15r cubed.
Right. You see why you need a sign? It's part of a polynomial. You can't omit the sign here. It wouldn't have any meaning. Okay. What's next?
Then it would be 3r cubed.
Plus 3r cubed.
Mm-hmm.
What's next?
9r.
What's next?
R squared.
What's last?
3.
Now combine that, combine like terms and simplify.
Okay, so I would combine. So I'd have 6. Oh, no. Take that back. 5r to the 5th plus 18r cubed plus r squared plus 9r plus 3.
And on these problems where you're doing multiplication like that, this first term, there's only going to be one of those, and there's only going to be one of these. In other words, there's only going to be one number. Mm-hmm. When you combine like terms, you're only combining the inside ones, basically.
Mm-hmm.
Okay? And now it's real easy to take the derivative of it.
Yeah.
What is it?
Would it be 25r to the 4th? And then 18r cubed. No. I'm reading the top, sorry. 64r squared.
I think that's 54.
54?
Uh-huh. 3 times 18 is 54?
Yeah, my bad. Plus r plus 9.
Plus 2r. Start with the exponent, put it in front. Plus 9. Okay. And that's your answer.
Sweet.
Now, I'm dying to teach you the product rule just because this is a perfect example of it, but I won't. It's not that hard. Your teacher will be able to teach it to you real easily. Let's see. What else we got? 29 through 31. That must be that original page I had open. This one here.
And then the next one's 29, I think.
Yeah, I got it. Oops. Okay. Here we're still just working with the power rule. So simplify that first, which means split it into 2 fractions.
Simplify it. Okay, so I take a w out first.
No, by simplifying it, what you want to do is combine that and subtract that. What's w cubed divided by w?
W squared.
What's w divided by w?
Just 1.
So that's what that function is that they gave us. And by simplifying it, I turn it into a polynomial, and now I can use the power rule. I couldn't use the power rule if I've got division going on or multiplication. Not if it's multiplication by variables. But if I don't, I can always treat it as a polynomial, but I got to simplify it before it's a polynomial. Now what's the derivative?
The derivative of this, it's just w minus just w.
Start there, always.
Oh, 2w.
Okay. Now you're supposed to do 30 and 31?
Yeah.
Okay. Split this one up into 3 fractions. That being your first one, you can figure out the other 2.
Okay, so that would be 3s.
What's s cubed divided by s?
Just s.
S cubed divided by s. You subtract the exponents.
S squared.
That exponent is 1. So
Yeah.
it's s squared. Okay? What's the middle one?
12s. I mean, no, I don't know what I'm saying. 2s. Minus 2s.
Good.
And then just 3 for the last one. Plus 3.
Plus 3. Okay, now take the derivative.
So it would be 6s minus 2.
Okay. And 30, rewrite. 30 is a little tougher to separate. What do you got to do to 30? I'm 31, I mean. How are you going to simplify 31?
I would just, I don't know how you do it, but like,
Always be thinking factoring if you don't know what to do.
I knew what you're supposed to do. I just didn't know. I just didn't remember the name.
Okay. So factor the numerator. What does it become?
X minus 1, x plus 1.
Now we're dividing by x minus 1. What's next step?
X minus 1 and x minus 1 cancel. So it's just x plus 1.
And what's the derivative of that?
Just 1.
Right. Okay. What's next up on your list?
All right, next. Okay, after this.
I'll go ahead and write it down if you want to give me all of it.
35 through 51 odd.
Okay, and then what?
52 through 58.
These go actually pretty fast because they're pretty easy. 52 through 58, all of it?
Yeah.
Okay. So 35.
Okay.
Whoops. Forgot. I am in writing mode. Okay. Find the equation of the tangent line. What's always our first step when they ask for the equation of a tangent line?
Equation of a tangent.
First of all, let's write the format we're going to use. What is it? What's point slope? We're always going to use point slope.
So it'd be y minus y1 equals m x minus x1.
Okay. So what's the first thing we need to figure out?
The slope.
Yeah. I was going to say, what's the most important word in calculus? Slope.
Slope.
That's why they spend all of algebra 1, 2 teaching you about slopes. Because when you get to calculus, slope is everything. So how are we going to figure out the slope here?
To find, would we just
First derivative? What's first derivative mean?
Yeah, we just take the first derivative and then plug in the points.
Yeah, first derivative means slope. That's what it means. So if I'm trying to figure out the slope of a function, first I take the first derivative. So what is y prime here?
It would be -6 x plus, no, just negative 6x.
Okay. And now what is y prime evaluated at 1? And that's kind of a combination of using f of x notation and y notation. In other words, the reason we use f of x is so that I can do this. And that's why we don't like to use y. But sometimes people will combine them. In other words, we're going to evaluate the y function or the derivative at 1. So what's the answer?
Just negative 6.
So that's the slope. And now I have this part of the equation. So negative 6. M equals negative 6. Now, let me erase some of this. Now fill in the rest.
Okay, so M equals negative 6.
Hold on. You got to start from left to right. Okay, I'll go with you here. Here, let's do it this way. Now we need a point. This is called point slope because you have a slope and you have a point. What is our xy point? What's our x value?
Our x value is a.
Which is y. What's the y value when x is equal to 1?
Negative 6.
Calculate that from the original function.
Oh.
We want the point on the original function. Remember, derivative, you're always thinking of the original function. And this point that we're evaluating it at is on the original function. When x is equal to 1, what is y equal to?
It would just be negative 1.
Okay, so there's our point. Now we can plug that point into that to end up with what?
Y plus 1 equals negative 6, x minus 1 in parentheses.
Yeah, and you want to leave it like that. You don't necessarily want to distribute all that.
Okay.
Okay, and you don't put it into y equal mx plus b format because that's really not the standard format for calculus. Point slope is the standard. Okay, so 36. What's the first thing we're going to do?
I think it's 37.
Oh, just odds? Oh, right. Yeah, sorry. Yeah. So, what's the first thing we're going to do?
Well, you can't really derive e of x because the derivative is the same thing.
Well, that you can do it then. In other words, you can't apply the power rule. The power rule you cannot use when your variable is in the exponent.
Well, yeah, that's what
a lot of people want to say that's x times e to the x minus 1. Well, that's not, you can't use the power rule for exponential functions. Okay? However, this function is very unique in math. It is the only function outside of 0 whose derivative is the same as the function. In other words, y prime equals e to the x. Okay? Now, what's the slope?
The slope.
Plug in the x value for x. That's going to be the slope. Just we'll write it out and then we'll simplify it.
So it'll be e to the line, natural log of 3.
Yeah. And that actually is the same as 3. In other words, as long as this is the same as that base, see where I'm pointing?
Mm-hmm.
And the answer is that. In other words, e to the natural log of x is equal to x. Always. No matter what x is. Okay? So that's our slope is 3. Now, let's figure out our point. What is our point?
Would we just plug in wait, no. Oh.
Plug in the x value into the original equation. That could be the x point.
So it'd be natural log of 3.
No, it'd be 3. In other words, the x point is going to be e to the natural log of 3. A is the x value. And that is 3. So our x point on this curve is 3. What's our y point?
I don't know.
Pardon me. I'm really confusing you. Sorry. I got confused for a second. Here. Sorry. Our x point is natural log of 3.
Uh-huh.
What's our y point?
3?
Yeah. Sorry.
Yeah, that's cool.
Okay. So there's our x and y value. We have a slope. Tell me what the equation is.
The equation?
Point slope format.
Would it be y minus 3 equals 3 x minus 3?
X minus natural log of 3. Remember, that's our x value, natural log of 3.
Oh, you're right. Okay.
Okay? And we don't want to put a number in there. That is a number, but we want to put it in as natural log of 3.
Okay.
Natural log of 3 is precise and exact. So our answer is that. Always.
Okay.
With calculus, you're never going to look that number up and put it in. They deal in precision. Okay, so we're doing odds 39. Keep track of the time here, because one thing that happens when I have it in this mode is it blocks out my clock. Okay, we got another 20 minutes at least here.
Yeah.
All right, 39. Let me see if I can move this page up a little bit. Yeah, it'll work a little better. Find the values of x for which the slope of the curve y equals f of x is 0. Okay. Keyword. How do we get that?
Derivative.
Okay, so what's f prime of x?
2x minus 6. So would I just
Hold on. I'm trying to figure this out. Find the values of x for which the slope of the curve y equals f of x is 0. Okay, so we take the slope of the curve and we set it equal to 0 and we solve for it. Solve that equation.
So it'd be 2x equals 6, x equals 3.
So
it would,
at the point x equal 3, if I were to graph that curve, at the point x equal 3, the slope of the tangent line would be 0. In other words, here's the kind of curve I'm looking at. If I go out to x equal 3, I know this curve is a parabola. Notice what the slope of the tangent line is when x equal 3. 0. As it always is at the vertex. So what we now have is a technique for finding the vertex of a parabola or a quadratic. Much faster than all of the techniques we've learned before now. In other words, precalculus, to find the vertex, you either had to put the thing in vertex format, or you had to use minus b over 2a, both of which are quite complicated. there's a lot of math involved in finding the vertex. But with calculus, all I got to do is take the derivative of the quadratic, set it equal to 0, and that tells me where the x-coordinate of the vertex is.
All right.
Now, it doesn't tell me where the y-coordinate is. If I wanted to know where the y-coordinate is, I will plug in x equals 3 into the original equation. In other words, I'll plug in x equals 3, and I'll get 9 minus 18 plus 5, which is equal to minus 4. Well, that's the y point. They didn't ask for it, but in other words, I didn't quite draw my graph right. The graph should have been drawn like this. I know now that the vertex is at 3 minus 4. It's a parabola. The vertex still has a tangent line that's horizontal. It always is going to.
Mm-hmm.
In other words, the tangent line at the vertex of all parabolas is always 0.
Okay.
That was 39A. Find the values of x for which the slope of the curve is 2. Well, our slope was, again, 2x minus 6. So how do I find where this is equal to 2?
So I just plug in 21 for x?
No, set it equal to 2. In other words, read what it says. It says where the slope of the curve is 2. That means the first derivative has to equal 2. In other words, these words right here, the slope of the curve is 2. And what that means is the derivative has to equal 2. Well, this is the derivative. If I set it equal to 2, I find out that when x is 4, the slope of that tangent line is 2. It's not 0. If I go back and I look at my curve that I had, and I go to x equal 4, I will see a slope, a positive slope of 2, like that. And we'll call that x equal 4. And notice that at x equal 3, the slope of the tangent line was 0.
Mm-hmm.
That's what this thing is trying to get at. Is you figure out, you couldn't go wrong in calculus, and believe me, this is true in derivative calculus and integral calculus. You can't hardly go wrong by always doing the first derivative as your first step, no matter what the problem is.
Mm-hmm.
I would say of every problem we'll do all year, at least 60 to 70% of them, our first step's going to be finding the derivative. Just know that, okay?
Okay.
That way you know how to start every problem. All right, let's look at 41.
Okay, find all points on the graph at which the tangent point is horizontal. How would I go about that?
What's my first step?
Obviously, derivative.
Okay, tell me what the derivative of that function is.
Okay, so it would be 6x squared minus 6x minus 12.
Okay, and they're saying, where is the slope horizontal? Well, what does that translate to? What does the slope need to be horizontal?
Vertical.
No. To be horizontal, the slope has to be 0.
Wait, horizontal or? Oh, sorry.
In other words, there's the horizontal tangent line. That has a slope of 0. Okay.
So do I just find the vertex?
You're not going to get any vertical slopes yet. That'll present a special case. But what they're saying now is, okay, where is it horizontal means the slope is 0. So I'm going to set, in other words, these two are the same questions. This question and this question are the same. This one merely says, where is the slope 0? 41 says, where is the slope horizontal? That means the same as 0. Now, solve that.
Okay, so
How many solutions are you going to get?
just one.
It's a quadratic. How many solutions do you get with a quadratic?
2.
Okay, so we better have 2 solutions.
But it's just,
There's going to be multiple points where the slope is 0.
but isn't it just a parabola though?
Right? How do you solve that problem right there? Think algebra. Algebra 2. Okay, let me give you another tip. If you don't know what to do next on a problem, what's the next thing to think about?
I don't know what to do.
Factoring. Slope and then factoring. Remember, if you're trying to solve limit problems and you don't know what to do, first thing you do is factor.
Okay.
Well, the way we solve this algebra, the way we solve this quadratic is factor it. What's the first thing I can do to factor?
3x and 2x in their individual
Let's make it
parentheses.
simple. Right now, I can divide the left side and the right side by a number to simplify this quadratic tremendously. In other words, don't make it harder than it needs to be. If you try to simplify something that has a 6x squared as its first term, that's going to be difficult. So can you get rid of that 6?
Yeah.
You can divide everything by 6, right?
Yeah.
Okay, when I divide everything by 6, I get this. Right side is still 0. Now factor that. That's not so hard to factor.
Yeah. So would it be x plus 1 and then x minus 2?
Okay, now you got your values. Where is the slope of this thing equal to 0?
It would be x equals 1 and x equals 2.
-1.
-1.
-1. And 2. Okay, this is a cubic function that we started with. This function right here
Yeah.
is cubic. So it's going to have some humps in it, like that. Okay, notice there's 2 places, there and there. So by taking the derivative of this cubic and finding out where the slopes are equal to 0, we find out key points. That's a minimum point in that function. And that's kind of a maximum point. Now, I should add the words relative. You haven't quite learned that yet. That might be coming up next for you after you learn some. I'm not sure when they'll teach you this, but you'll learn about absolute maximums of functions and relative maximums. You can see that that is a relative maximum, right? Not an absolute maximum. I got a point over here that's higher. But within a narrow range, that's a maximum. If I looked at that range right there, that would be a maximum. And it's called a maximum. It's called, it's not an absolute maximum, but it's called a relative maximum. And this point here is called a relative minimum. And there are millions of problems in the world where you have to find relative minimums and maximums of functions. This is the way you do it. You take the derivative and set it equal to 0. It's really one of the greatest discoveries in math as far as I'm concerned. Let's see, 43 is next.
Yeah.
For some reason, I may have to do something different here. I wasn't able to write. Can I write now? Hold on. I gotta unplug my drawing tablet and plug it back in.
All right.
And untangle it from all these wires. I move it back and forth so much that it gets tangled up. Can't see, it's getting dark in this room where I'm at. Gotta find the plug. See if that solved it. Nope. I have to close that and reopen it. This was this page here. Ooh, what is this? I don't like that. Whoops, sorry. Okay, should solve that problem. Let me zoom once. Let me get up to number 43. Let me take a picture. Hopefully everything will be copacetic now. Yeah, okay, good. So, finding slope locations, same problem.
On 41 it says find all points in the graph at which the tangent line has a slope of 60.
Sorry, I forgot that one.
Yeah, sorry, I don't know how I'd go about that one.
Okay. All right. Well, the derivative was again 6x squared minus 6x minus 12. And remember, that's a first derivative, so that's a slope. So if you're solving for where the slope is 60, make it equal to 60 instead of 0.
So I just do
That's
so
all.
what I just
You take the derivative, find the derivative function, and set it equal to whatever they want the slope to be. Here the slope is 0. Here the slope is 60. Here the slope is 21. So whatever that slope that they're looking for is, you put it on the other side of the equal sign.
So it'd just be 6x minus 6x squared minus 6x minus 72 equals 0, and then I just find the
Let's go ahead and divide everything by 6. We can simplify it pretty easily here. I think we do the same thing. So now we got x squared minus x minus 12 equals 0. In other words, you still solve quadratics the way you always solved it, which is to put everything on one side and 0 on another. You understand? I'm not putting 0 over there. We're not looking for a horizontal tangent line. We're just trying to solve this equation. And the way you solve a quadratic is to put everything on one side and 0 on the other. So now factor this.
So it'd be x minus 4, x plus 3.
And where are my 2 points? Where they're, I'm going to find a slope of 60.
X equals 4 and x equals negative 3.
Yeah, and if I were to plot this graph, that cubic, I would find that at x equal 4, I had a slope of 60, and at x equal minus 3, I had a slope of 60. So that kind of fits the, in other words, there's my slope of 60 at x equal minus 3. Here's my slope of 60 at x equal 4.
Mm-hmm.
Okay. All right. Thank you for not letting me pass over 41b. All right, 43. Same problem, right? Just different function. In other words, they want the horizontal slope, and they want a slope that's minus 1/2. So what's our first step?
Derive.
Okay, tell me what f of x, f prime of x.
So I get.
Let me rewrite this first for you. Rewrite it for me.
I get 2x.
Well, first rewrite it. 4x to the 1/2
Yeah.
minus x. Now take the derivative of that.
So it'd be 2x minus 1/2 minus 1.
Okay. Now we want to, that's not a quadratic anymore. That is, maybe it might be easier to solve this if I put it like this. Okay. You solve that for x.
Yeah, so I'd add 1.
Okay.
Multiply by root of x. And then just square it, so I get 4 equals.
All right. So that's the point where the tangent line is 0 or horizontal. Okay.
Okay.
Whoops, sorry. We're on this one down here. Now, solve it the second part. Whoops, hold on. So I got x minus 1. Excuse me, I got the derivative is going to be equal to what?
The derivative, negative 1/2.
Okay. Now you just got to solve that. That's not hard. You know how to you know how to solve that.
So yeah, I just get negative. No, I just get 1/2 equals 2 over root x.
Okay. So you get 2 over root x equals 1/2. Now what?
Cross multiply.
Okay. Now you get 4 equals root x.
And then 16.
Okay.
All right.
Yeah, this is the fun part of calculus, I think.
I like this a lot, actually.
Yeah, really. I mean, this is just, once you learn the technique, it's just repeating it.
It's just puzzles, pretty much.
Well, it's hard to learn the technique at first. Okay, so let's see. We're supposed to do 45. And it wants you to find the first derivative, the second derivative, and the third derivative for 45.
The first derivative, the second derivative. Okay, geez.
Much easier than you think.
Yeah.
What's the first derivative?
So 45, the first derivative would be 20x to cubed plus 30x squared plus 3, and then the second derivative would be 60x squared plus 60x, and then the third derivative would be
There's multiple ways to write it. I put 3 hash marks there. They put a 3. Means the same thing.
okay, 120x plus 60.
That's it.
Oh, that's pretty easy.
Yeah, when you're doing second and third derivatives, you're never doing them off the original function. In other words, to find a second derivative, you have to find the first derivative and then take the derivative of it.
Mm-hmm.
That was 45. Now we're looking for 47. There it is. Ooh. All right. 47. What are the directions for 47? Same thing. Find the first 3 derivatives.
Would they all just be the same?
Will they ever be the same? Only if it's e to the x. Then the first derivative is e to the x, second derivative is e to the x, third derivative is e to the x.
Oh, okay, that's
Okay, that's
good.
the only one where they would be all three would be the same. This one you got to do something first. What do you got to do?
For 50?
47.
Oh, 47. Would you,
You got division going on, right?
yeah, I'd probably just factor, right?
Yeah, you don't have a quotient rule yet. You'll learn it, and you could use it if you had it. But since you haven't gotten it yet, the only way we know how to do it at this point is by factoring the top and hope that you end up with an x plus 1 as one of the factors. Well, what's the top factor into?
The top factors into, I'd just probably assume x plus 1, x minus 8.
Yeah. And that's a good assumption. In other words, rather than expend the mental energy trying to factor it, assume one of the factors got to be x plus 1. Otherwise, we wouldn't be able to do anything with the problem. Okay? And that's correct factoring. Now I can cancel that and that. So that's really what f of x is x minus 8.
Huh, okay.
Find the first three derivatives.
So it would just be, it would just be 1 for the first derivative. And then the second derivative would just be 0. And then the third derivative would just be 0 too.
Yeah, and that's why I said the only other function besides e to the x is the 0 function. And y equals 0 is a function. So, and if you take lots of derivatives of it, you just keep getting 0. But it's not practical. In other words, there's no practical application for the fact that the derivative of 0 is 0, whereas the derivative of e to the x being e to the x is huge. That's one of the most important things in all of calculus, is that fact, is the fact that that's why that's such an important number, e. It's the second most important number in math after pi, as far as I'm concerned, and that's because it's so big in calculus. And the reason it's so big in calculus is because the derivative of e to the x is e to the x.
Okay.
So 49. Oh, I like these. Calculus is always fun when it's easy.
Yeah.
It's when it gets hard that it gets really tough.
Oh, yeah.
Or miserable. Yeah, it's 7 o'clock, but I want to do just one or two of these. Tell me if that's true.
That is definitely true.
It's definitely not.
Oh.
What you've done is applied the power rule, but there's no variable. That is not 10.
So it would have to just be 0.
Even if it was 10 to the x, that you couldn't use the power rule. 10 to the 5th is what? It's that number right there. What's the derivative of that number?
Just 0, because it's the first power. Okay.
Exactly. So don't let them fool you. And that's what they're trying to do in this section. The slope of the tangent line is never 0 because the derivative is e to the x. There's no solution to that problem. There's no way e to the x can ever be 0. If you look at the function e to the x, it looks like that. There's no slope there that's 0 anywhere. Okay. Let's just see if there's anything else. How about c? What's the derivative of e to the 3?
The derivative. It's just e to, oh, wait a minute. It's 0.
Yeah, very good.
Almost tricked me.
E to the 3 is just a number. And the derivative of e to the x is not that. It's e to the x. All right.
Yeah, that's fun.
Jake, this was a good session. I like this one.
Yeah, me too.
I like them all, but I mean, I love calculus. I really do. But yeah, this you can have fun doing this because it's not overly challenging. This assignment tonight?
Yeah, I was laid back. I liked it.
Yeah. And like I said, the next thing they're going to teach you is the product rule. And the reason you need a product rule so you can handle things like x times sine x. That's two functions that are multiplied together. You got to use a special technique for finding its derivative. But you'll learn that in class, and that will no doubt be our next session, is on product rule, I'm guessing.
Okay.
All right. Talk to you next time, Jake.
Yeah, you have a good night.
You too. Bye-bye.